In recent decades, the study of alchemy has posed a number of complications for historians of science. Among those who wrote as late as the 1960s, the general perception of alchemy had cast it in the mold of a quasi-mystical philosophy, a decadent obstacle from the Orient which stifled the progress of rational chemistry, and some even deemed it an expression of mental illness. Lately, however, this tendency toward reflexive dismissal has been curtailed as the wider community of medievalists, early modernists, and historians of science began trying to understand alchemy on its own terms, having placed it firmly within the context of a quote-unquote alchemical worldview, that is, its own internally consistent paradigm. The contemporary dialogue among historians of Western alchemy has chiefly been directed toward A. Understanding what the word alchemy actually meant to the people who lived directly in its midst, or even practice it themselves. B. Determining to what extent alchemy was interrelated with the religious consciousness of its practitioners. And most notably, C. Debunking myths by reconciling a number of exaggerated, artificial, and misleading dichotomies derived from modern, post-Enlightenment perceptions of medieval and early modern alchemy. Historians have asked themselves, was European alchemy a science or a pseudoscience? Was it a theoretical system or a practical art? Was it chiefly a spiritual or a material pursuit? Was it more so a medicinal or a metallurgical practice? How and when was alchemy differentiated from chemistry? Were alchemists on the fringes of learned society, or were they at the cutting edge of knowledge as defined by traditional institutions? And lastly, were alchemists outright frauds, Betrüger, or misguided fools? All of these are questions to which a handful of historians have recently turned, and ultimately have demonstrated to be somewhat misguided. Such dichotomies first arose from the dialogue in recent centuries wherein occultists, historians, chemists, and theorists from various disciplines began exploring and reconceptualizing alchemy and its history. Each discipline and each perspective offered one or another rather rigid model for understanding alchemy, and many of these models crystallized into opposing camps. Nevertheless, the reality is that alchemy has long eluded circumscription by any simple definitions precisely because, through the centuries, it was never a single static or monolithic pursuit. In response to this problem, it's my aim to flesh out some of the recent scholarly dialogue, to outline and synthesize the most pertinent points made in the recent historical literature concerning alchemy, with a particular focus on how alchemy fits into the narrative of the quote-unquote scientific revolution, with a capital S and a capital R. What I hope to demonstrate is that what today we label broadly as alchemy actually comprised of many different pursuits to many different people at many different junctures in history. With no source of official authority to standardize and govern alchemy as a clearly delimited branch of knowledge, such as via the church or the university, the art was free to take on and accumulate a number of its practitioners' idiosyncrasies. Unrestricted as it was in pursuit of understanding the natural world, Western alchemy came to constitute a rich and dynamic body of beliefs and practices, comfortably encapsulating within itself all of the artificial polarities I listed earlier. We cannot move forward in fleshing out a historiography of alchemy without first exploring two major debates from the mid-20th century which would irrevocably change how we interpret the scientific endeavors of the past. Namely, what is the difference between science and pseudoscience, and is there really such a thing as the scientific revolution? The former question was first addressed by the great Austrian philosopher of science, Sir Karl Popper. Popper began his work in Vienna between the two world wars, and although he was not a member of the famous Vienna Circle, he did have contact with the prominent logical positivists of his day. These interactions, nevertheless, were fraught with disagreement, causing him to develop a personal position distinguishing his own empiricism from that of his contemporaries. With the rise of Nazism, Popper fled Europe along with the other positivists, but eventually returned to a post at the London School of Economics, where he became a famous lecturer. Whereas the logical positivists worked out their theories of science as part of a broader project to develop a theory of language, meaning, and knowledge, Popper's chief aim was merely to understand science. In setting out to understand what science was, that is, the so-called problem of demarcation, he first had to determine what science was not. This is most relevant to our purposes because the history of the word pseudoscience is itself indissolubly bound up with the history of alchemy. In fact, the earliest known use of the word pseudoscience, according to the Oxford English Dictionary, dates back to 1796, with a reference by the historian James Pettit Andrew, who proudly referred to alchemy as a, quote, fantastical pseudoscience, with the implication that falsehood is the sine qua non of alchemy that distinguished it from true chemistry. Some century and a half later, after much deliberation, Popper would come to establish that the distinguishing factor between science and pseudoscience was falsifiability. In keeping with David Hume's radical inductive skepticism, Popper's falsificationism claimed that, quote, a hypothesis is scientific if, and only if, it has the potential to be refuted by some possible observation, end quote. Popper looked to the sciences, which were especially in vogue during his lifetime, chiefly Marxism and Freudianism, and determined that their claims about nature were ultimately non-falsifiable. This did not mean he believed these systems to be useless. He just simply did not consider them to be true science. To be scientific, a theory had to have skin in the game. A theory which took no risks at all was deemed unscientific because it could not be modified to fit any observation, as were, say, Freudian psychoanalytical theories or Marxist so-called laws about history. No matter the criticism, Popper maintained a Freudian or a Marxist could always find a way to make observations fit their theories. From there, the idea was eventually extended to the claim that all testing in true science takes the form of trying to disprove a hypothesis by way of observation. Conversely, it was impossible to confirm or concretely establish a theory by demonstrating that it merely agreed with observation. Simply put, confirmation is a myth. No matter how much observational data one had gathered, and no matter how many predictions one's theory had successfully made, observational testing could only prove a theory to be false. All we can say is that a theory might be true, a position which, thanks to C.S. Peirce, became known as fallibilism. Despite this insistence on the notion that we cannot confirm or even support our theories, Popper believed science to be a search for true descriptions of the world, what Peter Godfrey-Smith has called a kind of search for the Holy Grail. And here I quote, "All you can do is reject grails that are clearly not holy, since they stop glowing at some point, and keep picking up a new one. You will eventually die without knowing whether you succeeded." End quote. Popper was not suggesting that we give up searching for a true description of the world in a coma of self-induced paralysis by analysis, but that humans had to work with what they had. Certainty was merely provisional. Consequently, insofar as alchemy is remembered as a set of pursuits for the realization of specific goals, rather than the probing of its falsifiability, it is indeed correct to call alchemy a pseudoscience. Nevertheless, as we shall see, our picture of alchemy would become increasingly complicated when we were faced with the question whether it was really fair to call natural philosophical endeavors preceding the development of the modern scientific method as pseudoscientific. Enter the American physicist, historian, and philosopher of science, Thomas Kuhn. In his controversial but groundbreaking essay, The Structure of the Scientific Revolution, 1962, Kuhn sought to redress the idea that scientific endeavors were unscientific or pseudoscientific just because they had found their way into the waste bin of history. Kuhn believed that to emphasize the dichotomy between science and pseudoscience too harshly would completely efface the undeniably cumulative nature of science. In other words, Kuhn's definition of science was far more subjective and much less skeptical than Popper's. It does not serve historians to untangle Raymond Lull or Roger Bacon's relationship to modern science. Rather, it's better to know about these men's accomplishments from within the context of their own pre-scientific worldviews. It was this very context sensitivity, or historicism, which, as a philosopher and historian, Kuhn was the first to value. A value which did not necessarily sit well with his era's generally positivist view of progress. Therefore, in order to clearly discuss the existence of various blocks of historical context in the study of science, Kuhn appropriated the term paradigm. A paradigm, Kuhn argued, is an accepted scientific worldview within which exists a pattern he called normal science. Scientists acquired such models of normal science through education and worked at solving various puzzles that arose within their respective models in their quest to accurately represent or predict nature for whatever reason. This metaphor dominates Kuhn's system, with natural laws acting like the pieces of a grand puzzle that make up any given paradigm. Ultimately, transformations from one paradigm to another are as much a constructive process as they are deconstructive processes. As such, the cracking of puzzles by individuals is typically met with extreme cognitive dissonance and resistance by the aggregate. The Aristotelian, Ptolemaic, Copernican, Newtonian, and Einsteinian models are all examples of distinct paradigms with their own sets of internal consistencies. What made these scientific to Kuhn is that all these systems were functional in their predictive power to some degree or another, and retooling only became necessary when each respective paradigm was faced with a crisis. With the Ptolemaic system, for example, one did not need to believe that the Earth orbited the Sun in order to make accurate predictions about celestial events like eclipses or other planetary conjunctions. From Kuhn's perspective, crises arose within a given scientific paradigm when there came about a great proliferation of differing theories to explain away some given phenomenon by producing a multitude of exceptions, such as the Ptolemaic system's use of epicycles and epi-epicycles to save the appearances of the planet's little retrograde loops rising and falling in the sky. Or another example is the great multiplicity of phlogiston theories just before Lavoisier's breakthrough in chemistry, to the point that there was almost as many theories about phlogiston as there were chemical theoreticians. Paradigms shatter when a fundamental puzzle is cracked, leading to a more accurate way of representing what is observed in nature to take its place. Popper would refer to these as bold conjectures, and to him they also constituted the mechanism by which science progressed. Once a critical puzzle is solved by an irrefutable observation, the day-to-day humdrum practices of so-called normal science break down, and those trying to map out nature are forced to construct a new paradigm or become irreconcilably outmoded and obsolete. Two distinctly puzzle-minded paradigms are not only incompatible, but incommensurable. That is, they speak past one another, as the words they use to describe reality no longer bear the same meaning, and as such they might as well be speaking different languages. Pre- and post-revolutionary traditions of observing the natural world, therefore, were most incommensurable of all. Mass, for example, did not mean the same thing to Isaac Newton as it did to Einstein, and if they were to argue with one another, Newton would be unable to understand Einstein, who was working from within an entirely different paradigm, that is, relativity. What challenges cautious observers of nature, then, regardless of their historical context, is bringing their inherited puzzles and paradigms to completion through the daily grind of normal science until a breakthrough is made, such as Newton's inverse square law of gravity or Einstein's theory of relativity. Kuhn was accused throughout his life of having introduced a kind of radical subjectivity to science that undermined or eroded its slow but sure progress toward an ever clearer and disembodied objectivity. Kuhn's answer to this reproach was that he had no intentions of weakening or denigrating science with his idea of internally consistent and subjective paradigmatic worldviews, but rather to strengthen modern science's own awareness of how provisional even its own current models of understanding natural phenomena might be. One never knows when a new puzzle might be solved which could overturn the entire conception of the universe as it currently stands. From this perspective, alchemical pursuits like the transmutation of base metals into gold or the fabled search for the elixir of immortality were indeed the daily strivings of normal science, and not vain expressions of pseudoscience. Kuhn's suggestion had the effect of opening up the study of alchemy to move beyond its anachronistic depiction as a pre-corpuscular, pre-quantum revolution deceit. At last, alchemy could be considered in its own light, as a paradigmatic worldview unto itself, with its own questions, its own concerns, values, and interests, divorced from the unscientific teleology that has plagued most grand narratives revolving around the ideology of scientific progress. Not everyone, however, has been on board with this idea of reified scientific revolutions. In recent years, Peter Deer, among numerous others, has written extensively in an effort to dispel the grand triumphalist narratives which tout the existence of any definite scientific revolutions, let alone the scientific revolution. Deer's book, Revolutionizing the Sciences, examines to what extent it is fair to talk of medieval learning as fundamentally different from post-scientific revolution or Age of Reason thinking. A revolution implies the overthrow of a previous paradigm and its replacement with a new one. But Deer questions to what extent we can say that this actually occurred. He argues that we have to speak more of evolution and transformation, of small changes over time rather than overthrow and replacement. Thus, without denying the realities of change that make up most narratives in the history of science, Deer emphasizes the continuity in thought from one supposed era to the next. Galileo, for example, did not wish to do away with the title of natural philosopher. Rather, he merely wished to broaden its scope to include the practical dimensions of physics-mathematics, rather than merely Aristotelian logic chopping, as was still popular among the scholastics of his day. René Descartes wanted to replace Aristotle as the accepted philosophical authority, but he did not wish to overthrow the educational structures over which that authority held sway. The triumph of reason over irrationality is a matter of Enlightenment discourse. It's not necessarily a historical reality. Taking a more radically nominalist position, Deer sees it as an anachronism to retroproject the idea of revolution past the 18th century when it was invented, preferring instead to use it as a verb, revolutionizing, to soften the hard edges created by the historical periodization of science. Not unlike Kuhn, however, Deer perceives that the central goal of the history of science is to understand why people believed what they did within the context of their own times and societies, and that the historian should have, quote, no stake in adjudicating the truth of past convictions. Copernicus believed in a heliocentric model, and it is the historian's job to figure out the reasons why he believed it, with the currently accepted truth of the matter being entirely inconsequential. The medieval mind sought to understand the truth with a capital T. Therefore, the medieval mind sought to understand the truth of the natural world around it, while the modern mind seeks to predict and control the natural world. The former we call natural philosophy, which was an efflorescence of medieval university theology and scholasticism, while the latter we call science. As Peter Deer explains, a major difference between the two is that Aristotelian scholasticism sought to explain things that were already common knowledge, while modern science sought to make new discoveries, a concept which often borrowed from the discourse of 15th century explorers and sea navigators. This difference, however, came about through a slow process of mutation, not through a radical reformation in thought. Adherence to natural philosophical explanations merely gradually fell out of fashion. They were not forced out. His argument, then, is about the changes in sentiment concerning the knowledge of nature from something to be explained to something to be used. Deer stresses a process, which began in the 16th century, by which nature had to be mastered in order to be fully understood. In other words, if one wished to know about nature, one had to command it, and notable figures like Paracelsus or Francis Bacon populate his narrative in order to illustrate this idea. According to Bacon, it was only Aristotle's lack of the Christian virtue of charity which made him overlook the need for science to be practical, that is, to be useful toward altruistic ends. Ultimately, what Deer leaves out of his continuity-centric breakdown is the fact that evolutionary trajectories are largely shaped by long periods of stability punctuated by unexpected crises, violent disruptions of the status quo, and the cumulative effect of evolutionary bottlenecks. This is a fact which I think Kuhn's model of paradigms more accurately represents, even if it is fraught with the complications of essentializing labels. Most recently, David Wootton wrote his magisterial The Invention of Science to affirm, amidst all this tumult, that there really was a scientific revolution. He argues that just because scientific revolutions take time to unfurl, and just because there are a great multiplicity of scientific revolutions, so the Darwinian revolution, the quantum revolution, the DNA revolution, etc., this should not detract us from the main event, which was the invention of science itself. Wootton breaks down the term revolution into three types: the political French Revolution, the technological Industrial Revolution, and the scientific Copernican Revolution. And he teases out how the problematic over-application of the term revolution has lent to much confusion and debate. Now, Wootton admits that scientific and political revolutions only share in common the fact that they both radically changed people's lives. Scientific revolutions, however, are not deliberate acts, and to think of them as such is misleading. Nevertheless, there were, in fact, many rebellions of iconoclastic mathematicians against the authority of philosophers and theologians throughout history, and this in part is responsible for the prestige that science has over philosophy in universities today. And although Newton did not have such a concept as revolution in his own conservative culture, he did have the concept of a reformation, which could just as easily be applied to natural philosophy. The Protestant Reformation was indeed a vibrant example for demonstrating how quickly languages could be entirely reconstructed, and thus producing new, in this case theological, paradigms. A revolution in science would not come about until Lavoisier's Revolution in Chemistry, a term which was most appropriate to late 18th century France. But the idea hiding behind the word was not necessarily new. Moreover, we cannot dismiss that a revolution occurred either, so for example the genetic revolution or the digital revolution, just because it cannot be pinpointed as a single event in time and space. A nebulous and ill-defined cloud is still a cloud. Likewise, the fact that there is continuity throughout history before and after a revolution does not negate the element of change. Wootton's thesis is ultimately that, quote, sometime between the 1600s and the 1680s, science was invented. Wootton draws his line in the sand here, in spite of all the criticism levied over the recent decades, contending that the scientific revolution was composed of 5 distinct, independently developed events which intersected one another to create an entirely new worldview. These are the discoveries of Copernicus, Galileo, Brahe, Newton, Boyle, and their natural philosopher contemporaries whose investigations of the natural world challenged centuries of ideological orthodoxy deeply entrenched in places of power. Wootton argues that gunpowder, perspective, the printing press, the discovery of the New World, the telescope, the idea that there are laws of nature, and the very concept of discoveries or facts, all of these things converged to create an entirely new system of knowledge based on the values of truth and progress. Throughout his work, Wooten applies a postmodern lens to engage in a critical analysis of the very language of science itself and how it's transformed over the last 500 years. How science understood and defined itself throughout history, from terms like natural philosophy to science, or from physis forking into physics and physiology, to the relationship between astrology, arithmetic, astronomy, and so forth. What we find is that science is circumscribed by a complicated network of terms, and a change in the meaning of one term changes the meaning in the whole network. The transition from alchemy to chemistry was also marked precisely by one such process of linguistic change. Robert Boyle, whose dates are 1627 to 1691, was one of the chief figures of the scientific revolution, and he was still totally convinced of the reality of alchemical transmutation. During his lifetime, those who practiced alchemy did so because they were convinced the philosopher's stone had already been successfully produced in the past. Chrysopoeia, therefore, was a self-fulfilling enterprise. When experiments failed to yield results, it was thought to be because alchemists failed to follow instructions carefully enough. Not necessarily that the instructions themselves could possibly be misleading. In principle, alchemists had procedures for verification, like the trial by fire, but verification was not necessarily valued at the time, and thus it was constantly deferred. Moreover, as Wooten tells us, they had no procedure for falsification. Therefore, as new chemical discoveries were increasingly made through applying methods of falsification, the word alchemy became a wastebin label, a kind of graveyard for observers of nature to deposit failed hypotheses, with the label chemistry stealing away with the worthwhile fruits of alchemy's historically cumulative inheritance. From its formative stages in late antique Alexandria down to the present, alchemy evolved in a variety of independent, though eventually convergent, cultural and intellectual milieus. Since then, untold numbers of practitioners pursued the art for various reasons and in pursuit of various goals. The fact that it was a nebulous collection of ideas from different places and different times which came to constitute what we today call alchemy means there can exist no simple response in answering the question, what was alchemy? Nevertheless, in spite of having such disparate roots, some rather stable unifying features of the great work have been pinned down by historians. Alchemy was, as Lawrence Principe puts it, an endeavor of both head and hand. It was both theoretical and practical, textual and experimental, and these two aspects constantly interacted. Theories about matter and its composition undergirded alchemical aims and directed practical laboratory endeavors." End quote. In the form alchemy reached the Latin Middle Ages, however, it was the philosophical search for the agent of material perfection by means of the manipulation of base materials. By Paracelsus's time, in the 16th century, the term's usage had broadened to cover all manner of practices relating to the manipulation of the natural world. Understanding the interpenetration of theory and practice, or of science and technology, dispels the notion that alchemy was purely a wild-eyed, haphazard, and trial-and-error probing of alchemical processes. This does away with the 19th century romantic vision and retroprojection of the armchair spiritual alchemists, who inhabit an entirely speculative world and have fundamentally no material aim in mind. Seeking rather to perfect their souls by achieving ever subtler levels of observation, this idea emerged from an equivocation of the aspirations of ceremonial magicians with those of natural philosophers, though these groups were admittedly not mutually exclusive. Throughout history, there were, of course, individuals who leaned further on one end of the theory versus practice spectrum than the other. But the core feature of historical alchemy has been the consistent interaction of the theoretical and the artisanal elements. Alchemy, therefore, was a productive endeavor concerned with the manufacturing of everything from simple jewelry, coins, cosmetics, dyes, gems, tinctures, and pharmaceutical drugs, all the way to mysterious elixirs, universal panaceas, and philosopher's stones. In their variegated pursuits, alchemists gradually accumulated centuries' worth of knowledge on how to produce, identify, preserve, catalog, categorize, and manipulate countless material substances, laying out much of the practical groundwork for modern chemistry. Opposite to the literary musings of reactionary post-Enlightenment Victorian occultists, such as Thomas South, Anne Atwood, Ethan Allen Hitchcock, and William Wynne Westcott, who each tried to redeem alchemy by recasting it through a spiritualist interpretation that had not necessarily existed in the Middle Ages, that is, alchemy as ancient hermetic mystery chiefly concerned with self-transformation. Many 21st century historians of science have worked to break down alchemy's history into successive phases. They want to chart the changes in it over time and try to see alchemy through the eyes of its own practitioners rather than those of the 19th century imagination. Modern scholarship has thus been concerned with redefining the language that historians should use in order to prevent any confusion that might arise when discussing a term as misunderstood and as vague as alchemy. Throughout the literature, one finds a number of terms employed to distinguish one form of alchemy from another, especially across centuries of change. That is, chemeia, or pre-Arabic chemistry, chrysopoeia, or transmutational gold making, iatrochemistry, or medicinal alchemy, and chemistry, or early modern chemistry, etc. In spite of this increasing specification of language, historians like Lawrence Principe, William Newman, Tara Numedal, and Leah Devun have all sought to varying degrees to also maintain the level of ambiguity which a word like alchemy actually had to the societies within which it was practiced. Numedal suggests that, quote, "It is essential that we preserve this messiness rather than trying to oversimplify alchemy, or worse, anachronistically privileging one kind of alchemy over others based on our modern categories." End quote. In this approach, we can see how the long impact of Thomas Kuhn's acute sense of historicism and context sensitivity has helped steer the dialogue surrounding an alleged pseudoscience back into the light of honest historical inquiry. Openly sharing one's discoveries with a larger scientific community for universal recognition and admiration did not emerge as a value until at least the 17th century. As early as its formative period in late antique Alexandria, Western alchemy, or perhaps more appropriately chemeia, from the word cheo, I pour, cast, smelt, dissolve, etc., began as a lucrative practice of making tinctures and dyes which served to stain metals and luxury goods. While being committed to writing, such artisanal practices and materials were encrypted as religious and philosophically inspired decknamen, or code names, as means of safeguarding their authors' precious trade secrets. Centuries after Zosimus of Panopolis' time, following the Arab conquest of Egypt and their amalgamation into its learned upper class, transmutational chrysopoeia, the practice of refining base metals into more perfect forms, began to gain popularity among small circles of Ismaili Shiites who further impregnated alchemy with its seemingly initiatory character. Once introduced into Europe around the mid-12th century, a period of newfound literary prosperity, thanks to the proliferation of monasteries and schools, alchemy was split into numerous disparate yet mutually influential branches. Chrysopoetic branches, iatrochemical branches, and other more theoretically oriented branches concerned with questions of natural philosophy dating back to the pre-Socratic philosophers. From this point on, historians of science can see no clean break between alchemy and modern chemistry. Throughout the 20th century, one hypothesis proposed by Mircea Eliade gained widespread popularity as he argued that modern chemistry had been, quote, born from the disintegration of the ideology of alchemy. Alchemy posed as sacred science, whereas chemistry came into its own when substances had shed their sacred attributes. End quote. Though Eliade overemphasized the spiritual dimensions of alchemy, he was not altogether wrong insofar as he linked alchemy's decline into disrepute with the slowly unfurling disenchantment of Europe hypothesis. The key to studying the paradigm within which alchemists themselves operated, nebulous though it was, is that they perceived the natural world in a manner which differs fundamentally from our own. Medieval and early modern people in general, let alone the alchemists, did not neatly demarcate the sacred and the secular as most modern Westerners do today. As such, what we would currently consider the spiritual element of alchemy developed in tandem with, not in spite of, its fundamental materiality. The world of the alchemists was one in which science, magic, the imagination, the natural world, and God were all inextricably interwoven into one seamless tapestry. It was in this alchemical worldview or paradigm that all of our aforementioned modern dichotomies are dissolved and united. Before the development of our modern obsessions with taxonomy and categorization, people did not draw distinct boundaries between mundane and spiritual matters. Everything ran seamlessly. Whether for the Gnostic Zosimus of Panopolis or the Ismaili writers under the name of Jabir ibn Hayyan, the Franciscan spiritual John of Rupescissa, or the Renaissance occultist Paracelsus, spirituality colored everyone's worldview unequivocally. Alchemy everywhere was imprinted with the spirituality of its practitioners, not insofar as alchemy was, in and of itself, a spiritual practice, but because its practitioners could not conceive nor communicate things about their world outside of the language and symbolism of their paradigmatically spiritual or religious worldview. We can, therefore, still agree in a sense with the theory offered up by Eliade as to why alchemy slowly vanished into chemistry. The the gradual secularization of the Western worldview during the Reformation, the Scientific Revolution, and the Enlightenment had a direct impact on alchemy in their concomitant desacralization of science's language and symbolism. Thus ensued the gradual decline and death of the alchemical worldview, as its commensurable technical accomplishments were swept off to serve as tools in the new paradigm, while its incommensurable aspects were left behind to be forever scorned as monuments for mankind's credulous delusions. One object of persistent debate in the historical literature of alchemy pertains to the importance of alchemical cryptonyms, or decknamen, as they are most often called. These code names were used as early as late antiquity to disguise the material components and transmutational processes alchemists could perform with mystical language and symbols. Complex and inconsistently used code names such as the marriage of the sun and moon, or of the king and queen, saturate Western alchemical literature. Perhaps one of the best known collections of examples for these chemical allegories is contained in the so-called Emerald Tablet of Hermes. For much of the 20th century, over-speculation and confusion generated by these decknamen sat at the heart of the debates as to whether alchemy was primarily a spiritual or material practice. At one extreme, scholars like William Newman have interpreted the decknamen as mere mystical flavor, used to cover up chemical substances, practices, and processes, while, at the other extreme, generalists like Mircea Eliade overreached and fell more in line with the global and ahistorical interpretations of Carl Jung, who ultimately was more interested in what alchemical symbolism could tell him about the alchemist's collective unconscious. Instead of trying to understand the alchemists on their own terms, within the context of their own secluded paradigms, Eliade was more interested in mapping out a cross-cultural, magico-religious experience of mankind in relation to matter. Standing apart from both of these extremes, Leah Devun has forcefully argued that spiritual imagery, as used by John of Rupescissa, was neither trivial flavor nor the product of some ahistorical and cross-cultural unconscious phenomenon. Rather, spiritual imagery was central to the way Christian alchemists formulated and communicated alchemical theories with one another in the 14th century. Devun argues that, whether or not we realize it, modern science also operates on an allegorical level. We discuss the orbit of electrons, greenhouse gases, hydrophilic molecules, and despite being mere labels, such kinds of allegories define how we construct our maps of scientific understanding. Although these maps are socially constructed, they are indispensable to science's utility. Medieval alchemists were likewise influenced, even more so than modern chemists, by the language which they used to describe chemical processes. Whereas moderns look back to nature to elucidate the features of analogous natural processes, alchemists made use of religious or spiritual allegories. The encoded imagery used by John of Rupescissa, a Franciscan spiritual who lived through years of torture and incarceration, the Black Death, the 100 Years' War, and the Avignon Papacy, served three functions. One, to provide his practice with a theoretical basis, which ran parallel to the soul's journey through corruption, purgation, and salvation. Two, to act as an explanatory heuristic to make hard-to-grasp chemical processes clear to contemporary readers by linking them to spiritual concepts such as heaven, Christ, and resurrection, and 3, to serve as a rhetorical device which imbued Rupescissa's work with the weight and significance of an impending apocalypse. Devun's focus on Rupescissa's imagery, therefore, holds the deknomen neither as Jungian symbols bubbling up from the collective unconscious, nor merely as aesthetic veneers, but rather as an integral system of language used to theorize, communicate, and compel others to understand and share in his alchemical worldview. Zachary Mattis argues along the same lines in a recent article, claiming that although the vibrant code names and images might have obscured the minutiae of alchemical processes, for Christians they re-articulated the natural world in terms consistent with the principles of a Christian cosmos, and gave a direct purpose to scientific inquiry. For a radical Franciscan friar like John of Rupescissa, alchemy was simultaneously a pharmaceutical, that is, iatrochemical, and natural philosophical pursuit for the quintessentia, or the aqua ardens, that is, alcohol distilled via alchemical means. This he perceived as water, which easily turned into fire, which quickly evaporated into thin air, and which preserved all terrestrial matter. He thus understood this fifth element to be a celestial or superlunary substance, which was both perfect and immutable, just as the heavens themselves had long been believed to be, being entirely set apart from the traditional four elements that comprised terrestrial matter in various configurations, according to the Aristotelian paradigm. Rupescissa's alchemy, then, was an attempt to isolate and extract the incorruptibility of heaven and make it accessible for human use. The Franciscan alchemist was convinced that the product of his great work would ultimately serve to defend and heal the physical bodies of individual Christians in the face of the impending rise of the Antichrist. In a man like John of Rupescissa, therefore, all of the artificial dichotomies plaguing the study of alchemy are reconciled. For him, alchemy was a practical endeavor with theoretical underpinnings, aimed at a material transformation in the physical health of the church in order that they might prevail in the face of spiritual conflicts. His art unified sources of knowledge from within the university, that is, medicine, natural philosophy, and astrology, and from without, alchemical literature at the fringes. In his writings, Devun remarks, and I quote, "Transmutations, cosmology, and therapeutics all coexisted, subjugated to the service of one transcendental goal, the end of the age and the revelation of the meaning of human history." End quote. In this way, we also see how to judge all of alchemy as a pseudoscience is to judge it according to the values of an entirely different paradigm, despite the fact that it still delivered results relative to the goals of individual practitioners. For Philippus Aureolus Theophrastus Bombastus von Hohenheim, 1493 to 1541, more commonly known as Paracelsus, alchemy was likewise indissolubly linked with every other intellectual discipline he practiced. Paracelsus would ultimately become famous because he stood against the universities of his time on matters of medicine, iatrochemistry, and alchemy much in the way that Martin Luther stood against the universities in matters of theology, incidentally around the same place and the same time. Though Paracelsus was often wrong, that is, having contributed no lasting scientific discovery we still carry on with us today, what matters is that he was wrong and reasonable, and thereby he helped to dismantle an inherited paradigm which had long overrun its course. Tara Numedal writes that, quote, Paracelsus's place in the pantheon of alchemical authorities was always ambiguous for those who prized alchemy primarily for its promise to transmute metals. He sought to reorient the art away from the production of gold and toward medicine, disparaging alchemists who sought only to transmute metals. End quote. Although Paracelsus did not deny the possibility that Chrysopoeia could work, he was more focused on the new dimension of iatrochemistry, exploring its practical, theoretical, material, and spiritual dimensions, not as a replacement, but as an extension to the older astrological, natural magical, and alchemical traditions. By the 16th century, students of alchemy had an astonishingly diverse, yet paradigmatically consistent textual tradition to which they could turn. Medieval authors had provided them with a sophisticated theoretical groundwork toward alchemy's more practical applications, while a revival of Hermetic literature and philosophy by Renaissance humanists stressed an element of Neoplatonic spiritual theory, which was in turn applied to elaborate new pieces of alchemical artwork and decknamen. Where John of Rupescissa had seen Christ's death and resurrection take place in the Crucible and the Alembic, Paracelsus saw God as the supreme alchemist at the beginning and end of time, who, by his creation of an ordered world out of primordial chaos, was akin to the chemist's extraction, purification, and elaboration of common materials into chemical products, and his final judgment of the world was like the chemist using fire to purge impurities from precious metals. In a cosmological model such as this one, in the alchemical paradigm, the individual alchemist perceived himself as working alongside of God and hastening his work of perfecting nature along the great chain of being. In his recent biography of Paracelsus, Philip Ball confirms our observation in his insistence that modern readers must come to terms with the fact that, in the philosophy of Paracelsus, science and rationalism did not contend with mysticism and superstition. Rather, they were all fused together, producing a world that only now seems fantastic and bizarre. Now, let us compare these two exemplary alchemists, John of Rupescissa and Paracelsus, with Philip Sommering, the main character of Tara Numedal's monograph, Alchemy and Authority in the Holy Roman Empire. Sommering had arrived at the court of a duke in northern Germany in 1571, claiming the ability to transmute base metals into gold and silver. The alchemist also claimed to have knowledge on how to improve the productivity of tapped-out local silver mines, to design gun barrels which could shoot straight, and even to offer religious advice on the political problems posed by the Reformation. The Duke admired this amalgamation of, quote, intellectual, religious, medicinal, technical, and economic skills that alchemists had to offer, end quote, and he quickly negotiated a formal employment contract with Sommering and his assistants. While employed, Sommering faced heavy opposition from other members of the Duke's court, who would ultimately denounce him as a fraud for making too many promises and failing to deliver the desired results. fearing that these denunciations by local notables might persuade the Duke against him, since he had taken too long to produce the results he had guaranteed, Sommering attempted to flee and was caught and thrown into prison. Over the course of a year-long trial, the alchemist was not simply put on trial for fraud. He was accused of adultery, murder, attempted poisoning, sorcery, including the fabrication of charms and a love potion, copying keys illicitly, stealing state papers, and even fabricating an imaginary consultant. Sommering and his assistants were condemned to die by being drawn and quartered after having had their skin ripped off with hot iron tongs, as an example to others who might seek to profit by defrauding authorities. Numedal uses Sommering's story to illustrate how alchemists as late as the 16th and 17th centuries were no mere one-trick ponies, having had a hand in everything from intelligence operations to technological innovations, arms manufacturing, land speculation, and medicinal cures. A surprising number of people from various disciplines became associated with the title of alchemist. Whether in mining towns or imperial cities, they could be found taking on contracts to transmute precious metals in privately funded laboratories or acting as consultants for survey operations. They might survive by producing medicines or by making artificial jewels, glasses, and pearls. And while some, like Paracelsus, could practice their art with great success and still be considered alchemists, others, like Sommering, entered into bargains which they could not fulfill, whether wittingly or not. Throughout the Holy Roman Empire, men like these were labeled fraudulent impostors and dealt with forcefully. But this was not the reality which every alchemist necessarily faced. If we return to our above-mentioned categories, we see that the question of whether alchemists were outright frauds or merely fools is somewhat misguided. Standing from within their respective worldviews or scientific paradigms, few alchemists doubted that lead could truly be transmuted into gold, but many were extremely wary of the fantastic claims of those who professed the ability to do so without first offering evidence. Since there were never any alchemical authorities throughout European history, no place for alchemy amid the 7 liberal arts as upheld by the old universities, the validity of each alchemist's claims had to be judged on a case-by-case basis. Some men like Paracelsus and Rupescissa actually produced what they set out to produce, while other alchemists made promises which, whether or not they believed they could fulfill them, would eventually fail to produce the advertised results and ultimately find themselves in trouble. For as long as the head and hand alchemy was practiced, there was never a time when the discipline as a whole was deemed inherently fraudulent. While certain alchemical pursuits, like chrysopoeia, were gradually eclipsed by others, like iatrochemistry or geological surveying, the art as a whole, so loosely defined as it was never so monolithic that the failures of individual alchemists need discredit all of them. In his recent monograph, Solomon's Secret Art, The Occult in the Age of Enlightenment, Paul Kleber-Manaud stresses the fact that so-called occult beliefs and practices waxed and waned non-uniformly in response to the Enlightenment's broader scientific and cultural developments. Here he wisely defines the occult not as a reified tradition or static set of doctrines passed down through the centuries, but as a continuously negotiated body of discourse, or a hallway of mirrors, formed by the given culture, religion, politics, and professions of each individual occultist. That is, one who probes the world to reveal hidden phenomena. In some instances, occult pursuits competed against the new experimentalism of the 17th and 18th centuries, but in general, they simply operated in distinct realms of inquiry, with their own respective paradigms, unaffected by the fortunes of modern science. In his own words, Monod concludes that the occult was not killed off by science or the Enlightenment thinkers, but instead coexisted with them and borrowed from them. In other words, the idea that the so-called modern was born out of esotericism's clear-cut demise in the 18th century at the hands of mechanism, empiricism, and rationality has largely been exaggerated. Though the formal dialogue died out, there were no institutions by this point which actually had the power to consistently enforce occult philosophers, including the alchemists, to relinquish their pursuits. Moreover, it was precisely in this period that the volume of printed alchemical treatises reached its apex, despite how older historical narratives make it seem as if the practice of alchemy was then in steep decline. Monod lays out how this proliferation of texts was facilitated by the collection, preservation, translation, and publications of figures like the royalist lawyer Elias Ashmole or the book merchant William Cooper, publisher of the 1684 Collectanea Chymica. Isaac Newton here acts as a kind of poster boy for the message Monod's book elucidates, that cold, hard science and the occult were simultaneously employed without conflict throughout most of the 17th century. Though it is true many avoided all things occult during this era, it was not because they were skeptics, but rather because they were afraid of the hidden dangers intrinsic to summoning spirits or tampering with the fabric of reality. Ultimately, occult philosophers were fine with accommodating new scientific discoveries, but it was the experimentalist who, having birthed a new paradigm with his own set of values and puzzles, largely rejected occultism and its inability to reliably reproduce results for the scrutiny of others, a value which had not yet existed among the secretive and individualist practitioners of pre-modern science. Lastly, we cannot end this historiographical discussion without mentioning Mark Morrison's Modern Alchemy, Occultism and the Emergence of Atomic Theory, which frames the rise of atomic theory as a kind of revenge of the alchemists against the mechanistic, corpuscular worldview of the 18th century rationalists who dismissed chrysopoetic alchemy and its underlying paradigm. As late as the early 20th century, alchemy was vindicated in a most unexpected arena when chemist Frederick Soddy and physicist Ernest Rutherford, working in a lab at McGill University in 1901, discovered that radioactive thorium was transforming into an inert gas. Immediately, Soddy realized with a sense of exhilaration that what they were performing was, quote, a transmutation. For Mike's sake, Rutherford snapped back in a hushed tone, don't call it a transmutation, they'll have our heads off as alchemists. For indeed, at that time, the emerging science of radioactivity had frequently provoked comparisons to alchemy in the popular imagination. Some even imagined Marie and Pierre Curie's radium to be a modern-day philosopher's stone. By the 1920s, atomic physics and radiochemistry were being frequently referred to as modern alchemy in the press. While Rutherford had first had an instinctively cautious reaction to the comparison, in the end, even he eventually gave in to the popular appeal and published his last book in 1937 under the title The Newer Alchemy. Morrison explores the many ways in which the most cutting-edge discoveries of early 20th century science were being cast in the discourse of an ostensibly outmoded and discredited pseudoscience. In part, this was on account of the perceived analogy between the worldview of the atomic theorists and the unrealized dreams of the medieval alchemists who tortured lead into gold and ultimately proved the Neoplatonic doctrine of the fundamental interconnectivity of all things at the basis level of reality. Hen to pan, the all is one. This doctrine had been thrown to the wayside as the mechanists of the 18th and 19th centuries, with their corpuscular billiard ball conception of matter, and their discovery of many new individual and indivisible chemical elements. Leading up to Soddy and Rutherford's discovery, let alone the whole quantum revolution, ceremonial magician and Golden Dawn founder Wynne Westcott prophetically wrote, restating the purported theoretical goals of the alchemical worldview, and I quote, "The discovery of the elements has been the grand achievement of modern chemistry. But if we may trust one of the most eminent chemists of the day, Professor Crookes, the future will change all this system, and a niche in the Temple of Fame will in the future be allotted by preference to one who succeeds in dividing one of our present elements into its constituents. The chemistry of the future is to destroy the present theory, and to gain the power of reducing all compounds and all elements to one primordial matter, to be named protyle. In other words, the most ancient chemical doctrine of the first matter is to become paramount. This, then, is the reconciliation of the future. No sooner is the modern doctrine of elements laid aside than the discoveries of primordial matter, the transmutation of metals, reappear once more and enter the range of the possible." End quote. So, as we can see, one component which went into the alchemical conceptualization of atomic science was the prevalent fin de siècle revival of interest in alchemy as esoteric religion. This occult efflorescence actually had an impact on how scientists understood and portrayed their research, and it fed back into the language of the emerging science of radioactive transformation. So the book Modern Alchemy is not saying that atomic theory arose directly out of 19th century alchemy or occultism, but that widespread interest in alchemy gave chemistry a trope with which to influence public reception and the sense of its own identity. And incidentally, the trope contributed to the early phases of understanding of radioactivity's significance. In conclusion, we have seen how the most recent dialogue among historians has been directed toward understanding what historical alchemy really meant to the people who practiced it, on defining to what degree alchemy was interconnected with spirituality, and on reconciling a number of extreme polarities which arose from a dualistic approach to various debates surrounding the nature of alchemy. We have seen how European alchemy was simultaneously a practical art with a theoretical foundation. It was a material pursuit defined and given meaning by spiritual worldviews. It could be both or neither an entirely pharmaceutical or metallurgical art. We have seen that there was no clean break between alchemy and chemistry, and therefore how alchemy was both a legitimate science and a pseudoscience, depending on who we ask and what results we are expecting it to deliver. We have seen how, even in the 17th century, the title of alchemist did not intrinsically denote a fraud or a fool to the society in which he lived and worked. Rather, these labels depended on whether individual alchemists could live up to the promises they made to wealthy and irascible patrons. The breaking up of alchemy's history into phases has, I hope, helped to dispel some of the more monolithic, cross-cultural, and ahistorical interpretations which historians have constructed in the past. Taking the spiritual element of alchemy seriously, we've seen how its religiously inspired language and symbolism was no simple mystical flavor, but it served formative, heuristic, and hortatory functions. Christian themes in European alchemy, for example, rendered chemical processes meaningful and thus more intelligible to a wider audience. Not only was Western alchemy expressed in spiritual nomenclature, but it was defined within the bounds of Christian cosmology, an entirely distinct paradigm from the one which we use to interpret the natural world today. The wholesale rejection of alchemy as an obstacle for scientific inquiry is ultimately a relatively modern reaction. But among the societies wherein alchemists lived, legitimacy was determined on an ad hoc basis. If we may draw only one conclusion from the foregoing, it is that no branch of historical inquiry should operate by projecting rigid categories and modern definitions onto the past to explain amorphous phenomena. Rather, historians, and especially historians of science, should strive to let bygone societies speak to the present from within the context of their own paradigms. You've been listening to Forgery and the Crucible, a historiography of alchemy, pseudoscience, and the scientific revolution. Written and narrated by Dan Attrell.